Hello everybody, my name is NaderTater24, and in today's video I want to show you guys a new math notation slash function, well, a function with its own notation a little bit, to all you guys. I want to call this thing, wait, wait, first, I want to show you what this does first. So, this has similar variables or inputs or whatever, like the sum and product function. So you have the number that this variable will end at, and the starting value of this is like what I know of the sum and the other one. Then we're gonna add a new variable to this. This one's for hyper operations, so you can like change the operation. So 1 would be addition, 2 would be multiplication, 3 would be exponents, 4 would be tetrration or whatever, and it will just so on repeating functions, getting more and more, I don't know, crazy, I guess. Now I've only used this function in one way, which was just not really doing anything to n, just letting n do that. do that. So an example how this would work, it would be like so an example of how this thing would work. So if you set this, let me redraw it real quick. So let's say we have 3, 1, and n equals 1, n. This will be equivalent to the sum of 3 n, where n is equal to 1. I drew that really funky, but it will be equivalent to this sum function because of the operation that it chose, which is, so it's repeating addition. The sum function repeats addition. Now, if you were to change the operation to multiplication, then it will be also equivalent to the product function. It can be rewritten like this when this is set to 2. Now, what makes this function unique is that you have all the hyper operations that you can use, like infinite really. But the increasing this number right here would change the will make the numbers increase really, really fast. Now, the number right there can only be whole numbers, sadly, because there isn't an operation that's between exponents and tetration from what I know right now. There's not like a operation that's between that from what I know. So this can only be whole numbers. But still, there's a lot of things you could do with this. Let me show you an example of how big numbers can really get. We're going to only move up to exponents here, where let's say let's do 4. Well, no. 5. That one's more crazier. All right. So this can be written as 2 by the power of 3 by the power of 4 by the power of 5. And because it's 3, that's why we're doing exponents. And this, if you don't already know, is an extremely large number. So 4 by the power of 5, let me just look that up. 4 to the power of 5, that's times, hold on. 4 to the power of 5, 1024. So you'd go back 2 by the power of 3 by the power of 1024. This is when it starts getting crazy. Now, the closest I've got to solving it, actually, I have solved it, but I've put it to scientific notation and rounded it. So it's equivalent to about 8 point, actually no, I just 8 times 10 to the power of 121. Yeah, 121 digits long, or 121 digit number. And we're only using exponents. We're not even going crazy and using tetraration. So that's my new, so that's what I wanted to show you. I want to call this the hyperfunction. I wrote that funny. I want to call it the hyperfunction. Or maybe, yeah, I want to call it the hyperfunction. I hope some mathematicians see this video and take this into consideration, because I worked hard on this and I thought it was a pretty interesting and unique idea I haven't heard anyone else do before. Alright, see you guys in the next video. Goodbye.